Selection sort is probably the simplest sorting algorithm. The idea behind selection sort is simple. Split the input array into sorted and unsorted part, find smallest number in unsorted part of array, and swap it with first number of unsorted array. Then we move the first number of unsorted array and add it to the end of our sorted part. We are going to use something called wall. So on the left side of our wall we have sorted part, but on the right side we have unsorted part. And we put our wall at the beginning of our array because we haven't sorted any number yet. Now, as the algorithm says, we are going to find the smallest number in the sorted part. But computer is not a human. He cannot see that 1 is the smallest. So he has to compare every number in unsorted part and then he knows the smallest. So we take first number of unsorted part and compare it with every number behind. If we find smaller number, we are going to mark that number as the smallest and once again we compare it to numbers behind. When we reach the end of unsorted part, we know that we have marked the smallest number. So we take 16 and compare it to 5. 5 is smaller, so we are going to mark that as smallest, and now we will compare 5 with numbers behind. We see that 5 is smaller than 11. That means we move on to next number. Now we compare 5 and 8, and once again move to next number. We compare 5 and 1 and see that 5 is bigger, so we mark 1 as smallest and continue towards the end. We compare 1 and 2. Obviously, 1 is smaller, so we move on. And compare 1 and 20. Once again, 1 is smaller. We have reached the end. So we have found the smallest number in our sorted part. Now, as the algorithm says, we are going to swap it with first number of our unsorted part. So we have the smallest number at beginning and we can go ahead and move our wall by one number. And we do this until we have only one number in our unsorted part. So once again we are trying to find the smallest number in unsorted part. So we take 5 and mark it as smallest and compare it to 11. 5 is smaller, so we move on to 8. Once again, 5 is smaller, so we move on to 16. Now we compare 5 and 2. 2 is smaller, so we mark 2 as smallest and continue with numbers behind. In this case, we compare 2 with 20 and 2 is smaller. If there were any other numbers, we would continue, but there are not any. So we swap the smallest number, in this case 2, with the first number of our unsorted part. Now we have the smallest number at the beginning, so we move our wall by one number. I think you should get it now, so I'm going to do the rest a bit faster. Basically what we do is we find the smallest number in unsorted part and add it to the end of sorted part. So we compare 11 and 8. 8 is our new smallest number, moving on to 16 where nothing happened. Now we compare 8 and 5. We compare 5 to the numbers behind and see that 5 is smallest. We swap it with first number and move our wall by one number. In the next iteration, we find out that 8 is the smallest number in unsorted part. But 8 is already first number in unsorted part. Well, that is just less work for us, because we don't have to swap anything. We just move our wall. In the next round, we find out 11 is smallest. We swap it with 16 and move our wall. Even though this array is already sorted, computer doesn't know that, so he will go through one more iteration and compare 16 and 20 and add 16 to the end of our sorted part. And once we have only one number, we know we are done.